Over 100 million plasma TVs sold worldwide. Then in about 10 years, every maker walked away. The same glowing gas cell that gave plasma the best picture also killed it. Here's how the best lost. Here's the strange part. Plasma didn't lose because it looked bad. It looked incredible. Deeper blacks, smoother motion, and wider viewing angles than any flat panel of its day. LCD couldn't touch it. Reviewers begged you to buy one. Yet by 2014, Panasonic, Samsung, and LG had all quit. Why does the technically better screen lose? The answer isn't the picture. It's one gas cell running too hot. Start with what made plasma magic. Look at one dot on the screens. One subpixel. Inside is a sealed pocket of gas, mostly neon and xenon. Hit that gas with a jolt of voltage and it turns into plasma. A hot, glowing state of matter that spits out ultraviolet light. That's the term in the title, plasma. It's just gas energized until it glows. The ultraviolet light itself is invisible, so each pocket is coated with a phosphor, a powder that soaks up that light and glows red, green, or blue. So every dot is basically a microscopic fluorescent tube. Now multiply. A plasma panel has millions of these tiny tubes, one per subpixel, and each one is wired to switch on and off by itself. Here's why that mattered so much. When a cell is off, it makes zero light. None. So plasma black wasn't dark gray. It was truly black because that part of the screen was simply switched off. Compare that to an LCD. An LCD has one big backlight blasting through the whole panel all the time, and tiny shutters try to block the light where the image should be dark. But shutters leak. A little light always seeps through, so LCD black is really dark gray. Plasma had no backlight to leak. Each dot was its own light and off meant off. That single design choice, every pixel glowing on its own, is the whole reason plasma's blacks became legendary. Remember that idea, a screen where every dot lights itself. Because it comes back at the very end. But that same self-lighting design carried a hidden bill, and it starts with heat. Here's where it gets expensive. Literally, every one of those glowing cells is a real electrical discharge. To light a bright frame, a plasma panel fires millions of them over and over every second. Firing that many tiny lightning strikes burns real power, and real power turns into heat. So plasmas ran hot. Put your hand near one after an hour and you could feel it, like a warm radiator in the room. And they were thirsty. A 50-inch plasma could pull 300 watts or more. A comparable LCD sipped around 100 watts. Say that again, 3 times the electricity for the same size picture. That gap did 2 kinds of damage. First, the obvious one. A bigger power bill every month and a warmer living room every summer. But the second kind of damage was the one plasma never saw coming. Right around this time, energy efficiency labels became a selling point. Governments pushed efficiency ratings. Stores started printing the yearly running cost right on the shelf tag, next to the price. Suddenly, a shopper standing in the aisle saw 2 numbers, what the TV costs to buy and what it costs to run. Plasma lost the second number badly. The very thing that made its picture glow, millions of little discharges firing constantly, was now a red flag on a sticker. A screen that was praised by reviewers started looking wasteful on paper. That's a brutal place to be. And heat was only problem 1. Problem 2 was quieter, and it scared buyers even more because it was permanent. Problem 2, the picture could scar itself. Those phosphor powders, the coatings that actually glow red, green, and blue, wear out a little every time they light up. Now think about what sits still on a screen. A channel logo in the corners. A news ticker crawling along the bottom. A game's health bar and score frozen in the same spot for hours. In those exact spots, the phosphor fired constantly while the rest of the screen rested. So it aged faster there. Leave a bright logo on long enough and that patch of phosphor dimmed unevenly, and a faint ghost of the logo stayed on screen. Even after you changed the channel. That permanent shadow has a name people came to dread, burn-in. And it wasn't only sharp logos. Across the panel's whole life, all the phosphors slowly faded. A plasma that was dazzling on day 1 was measurably dimmer years later. Makers fought back hard. They added features that gently shifted the picture a few pixels, screensavers that kicked in on a paused image, and better phosphor mixes that aged slower. By the later years, real-world burn-in was rare. But here's the thing about fear. It doesn't need to be common to kill a sale. A shopper only had to hear one horror story about a permanent shadow to feel it. Would you spend a month's pay on a screen that might scar? Many people quietly said no and bought the LCD instead. So Plasma was now fighting heat and fear at the same time. But the blow that really boxed it in wasn't about the picture at all. It was about size. Problem 3 is the one people forget, and it may be the deepest. Plasma could not be made small. Remember, each dot is a physical pocket of gas that needs real room to glow. Shrink the cell too far and there isn't enough gas to make a bright, stable spark. So Plasma had a floor. Below a certain size, the technology simply stopped working. That sounds like a minor limit. It was actually fatal. Think about where LCD went. The very same LCD technology scaled from a tiny watch face, up through a phone, a laptop, a computer monitor, all the way to a wall-sized TV. One family of screens, billions of units, in every device you own. Plasma could do none of that. No Plasma phones, no Plasma laptop, no Plasma monitors. It was trapped in one room of the house. The living room on the big set. And that trap had a money side that decided everything. When you build LCD panels for phones, laptops, monitors, and TVs, every factory improvement and every dollar of research gets spread across billions of screens a year. Each panel gets cheaper. Plasma's research had only one product to pay for it back: the big TV. Fewer units, so every improvement cost more per set. On top of that, Plasma panels were thick, heavy sheets of sealed glass. A glass sandwich you needed 2 people to lift. LCD kept getting thinner and lighter while Plasma stayed a slab. So Plasma wasn't just losing a picture argument. It was a specialist fighting an entire industry that got cheaper every single year. Which sets up the final blow. The one fought right on the showroom floor in dollars. Now the knockout. It came down to price on the showroom floor. Because LCD shared its factories with phones, laptops, and monitors, its costs fell fast and kept falling. And while prices dropped, LCD quietly closed the picture gap. Early LCD was dimmer and blurrier than Plasma. But year by year it got brighter, sharper, higher resolution, and thinner. Then LED backlights made it brighter still. By the early 2010s, a shopper standing in the store saw 2 big screens that looked close. Really close. One was a Plasma running hot, wearing a scary energy label whispering about burn-in. And priced higher. The other was a thin, bright, cool-running LCD that also worked in your phone and laptop. And cost less. Same wall of the store. And here's the quiet truth about how people actually buy. Most shoppers can't see the difference Plasma fans obsessed over. In a bright showroom, Plasma's deep blacks barely showed. The room lights washed them out. What every shopper could read was the price tag and the smaller number 1. Plasma still had a real edge in a dark room for the picky viewer who set it up perfectly. But you can't sell a premium on an advantage most buyers never notice at the exact moment they're deciding. Once LCD was thinner, cheaper, cooler, and good enough, Plasma's one true strength, those perfect blacks, no longer justified paying more. The premium had nothing left to stand on. That's not a picture defeat. That's a math defeat. And the math was over. So here's how it ended. Panasonic, the last true believer, made the best Plasmas on Earth and defended the format to the last. Then stopped making them in 2014. Samsung and LG walked away in that same stretch. Over 100 million sets sold, and inside about 10 years the whole category was gone. Read the verdict carefully because it's the real lesson. Plasma did not die because it was worse. It died from heat, from the fear of burn-in, from being unable to scale down to phones and laptops, and above all from the economics of scale. One product versus a whole industry that got cheaper every year. The best picture lost the price war. But here's the twist, and it's a good one. Remember that magic idea, a screen where every single dot makes its own light and off means truly black. That dream didn't die with Plasma. It came back. It's called OLED, and OLED pulls off the exact same trick. Perfect self-lit blacks. But with no gas, almost no heat, and a panel thin enough to bend. Plasma had the right idea. It just had the wrong body. So the lesson outlives the format. The best picture doesn't win the living room. Scale and price do almost every time. Plasma proved it, then handed its dream to OLED, the screen that lights every dot on its own without the heat. You've seen how the old king fell. Next, meet the heir, how OLED makes light out of nothing but electricity.